Let's talk about Bohr's atomic model that is based upon the Planck's quantum theory. The Bohr's atomic model is superior to the Rutherford's atomic model. It is distinguished as it firstly presented the concept of orbits and the energy levels. In the Rutherford's atomic model, it was said that the electrons revolve around the nucleus and emit energy continuously. If that was true, electrons, while revolving around the nucleus, lost all of their energy and ultimately fall into the nucleus, and the structure of atom would collapse. So the Rutherford's atomic model was not satisfactory. Using the Planck's quantum theory, Bohr presented the atomic model. In the Planck's quantum theory, it was said that energy is emitted discontinuously in the form of quantum. So Bohr postulated that the electrons revolve around the nucleus in one of the circular orbits whose energy is quantized. Bohr postulated that the electrons revolve in circular orbits and do not emit the energy continuously, and the energy of every orbit is quantized or fixed. This is how the structure of an atom presented by Bohr looked like. The central positively charged dense part is the nucleus, which was discovered by Rutherford, and outside the nucleus there are the circular orbits. These orbits are spaced from the nucleus at a certain distance. Electrons revolve in these orbits only. While revolving in a particular orbit, electron does not emit or absorb energy. It only emits the energy or absorbs the energy when it jumps from one orbit to another. If it jumps from inner orbit to the outer orbit, it absorbs the energy. When it jumps from outer orbit to the inner orbit, it emits the energy. The difference of energy between these two states is given by delta E, which is equal to E2 minus E1. E2 is the energy of electron in newly occupied orbit, and E1 is the energy of electron when it was in its native orbit. And that is equal to h mu, where h is the Planck's constant and mu is the frequency. And h mu is the photon of light, which means that electron jumps from one orbit to another orbit and emits or absorbs photon of light. As the electrons revolve in circular orbits, they possess the circular motion. And for circular motion, there must be the angular momentum. The angular momentum of an electron moving in one orbit is fixed, which is given by mvr and is equal to nh divided by 2 pi. In this equation, m is the mass of electron, v is the velocity of electron, r is the radius of orbit from the nucleus, and n is the principal quantum number. N shows the orbit in which the electron is residing. H is the Planck's constant, that is equal to 6.626 cross 10 to the power minus 34 joule second. And pi is definitely equal to 3.14. In this equation, only radius and principal quantum number are the variables. The principal quantum number n is the value or digit or a number that is assigned to every orbit, and its value starts from 1, 2, 3, and so on and ends at infinity. The orbit closest to the nucleus has a value of principal quantum number 1. Outside the first orbit, second orbit has principal quantum number 2. For third orbit, it is 3, and it goes on ascendingly moving away from the nucleus. As every orbit has fixed energy, so the energy of first orbit is E1, for second orbit it is E2, and for third orbit it is E3. The principal quantum number and energy are related to each other as E is equal to minus 1313.31 into 1 by m square. This equation shows that energy of electron in an orbit or energy of the orbit is inversely related to the negative of square of principal quantum number. Its physical meaning is that energy of an orbit increases. The energy of orbits goes on increasing as you move away from the nucleus. So the orbit that is away from the nucleus has a high energy and the orbit that is close to the nucleus has lower energy. The lowest energy is for the first orbit as it is closest to the nucleus. The difference of energy between two orbits is not regular. The difference between first and second orbit is the greatest. For third and second orbit, it is lower than that calculated from second and first orbit and goes on. The difference of energy between two orbits doesn't remain constant. This is because as the orbit move away from the nucleus, they are less influenced by the positively charged nucleus. This is how the energy and principal quantum number are related to each other. Now let's talk about the radius. That is the distance of each orbit from the nucleus. For first orbit, it is R1. For second orbit, it is R2. For third, it is R3, and so on, and ends at R infinity. The radius is also related to the principal quantum number by this equation. It is equal to 0.529 angstrom times n square, and n is the principal quantum number. By putting the value of principal quantum number 1, 2, 3, and so on, you can find out the radius of orbit from the nucleus. For first, second, third, and so on. For every orbit, you can find out the value of radius. This equation is showing that the radius is directly related with the square of principal quantum number. The difference of distance between two orbits is also not constant. The distance between first and second orbit is the lowest. For third and second orbit is greater than that calculated previously. The distance of each orbit from the nucleus is not regular. As you move away from the nucleus, the difference of radius between two orbits goes on increasing. This was all about the Bohr's atomic model. He said that the electrons revolve around the nucleus in circular orbits and emit energy in discontinuous manners. Electrons only emit the energy when they jump from one orbit to another, and when they jump from lower orbit to the higher, they absorb the energy, and when they jump from higher to the lower orbit, they emit the energy. Each orbit is given a number which is known as the principal quantum number. Each orbit has a fixed energy that is quantized, and the difference of energy while moving away from the nucleus and the difference of energy for every orbit while moving away from the nucleus is not regular, and the energy of the orbits while moving away from the nucleus goes on increasing. Same is the case with the radius. The radius also increases while moving away from the nucleus, but the orbits are not equally spaced from each other. This was all about the Bohr's atomic model. Bohr used spectrometry and studied extensively the emission spectra of hydrogen atom to put forward the structure of hydrogen atom. He successfully explained the structure of hydrogen atom and the systems which contain one electron. He worked tremendously to calculate the energy and radius of orbits. But his model also has certain defects. First of all, the spectra Bohr studied didn't explain the Zeeman and Stark effect. Zeeman effect is when the spectra is studied under the application of external magnetic field. The spectral lines split up into several very fine lines. This effect is the Zeeman effect. This is the spectra when applied with external magnetic field. The spectral lines, these white colored lines, which are showing the emission spectra, split up into several very fine lines. This effect is called Zeeman effect, and Bohr didn't explain it. Secondly, Bohr didn't explain the Stark effect, which is the splitting of same spectral lines into same fine lines while applying the external electric field. Thirdly, Bohr didn't explain the fine structure in spectrum. But when the spectra of hydrogen atom is studied under the high resolution power spectrometer, the spectral lines split up into several lines. This is known as the fine structure in a spectrum. This effect is observed in hydrogen atom. The H alpha line in the Balmer series splits up into 5 components, which is showing that the principal quantum number which the Bohr used only is not enough to explain the position of electron around the nucleus of atom. we need the other quantum numbers too. Fourthly, the Bohr presented 2D model of atom. He said that the electrons revolve around the nucleus in two-dimensional axis. Later on, it was shown that the model of atom is 3D. The electrons revolve around the nucleus in three-dimensional axis, x, y, and z axis. The Bohr atomic model is applicable to the single electron systems only, like hydrogen, helium positive, lithium 2 positive, B3 positive types of species. It fails to explain the structure of polyelectron systems. This was all about the Bohr atomic model, its postulates, its benefits, its structure, and the defects of Bohr atomic model. Like, share, and subscribe to my YouTube channel, and thanks for watching.